assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So this problem gives us the reaction CO gas plus H2O gas reversibly forms CO2 gas plus H2 gas, and gives us that we have a Kc of 102 at 500 Kelvin. And so we're given the initial concentrations of CO and H2O, and we assume that the initial concentrations of CO2 and H2 are 0. And so we can set up an ice table. So this will be initial, and I'll go across CO, H2O, CO2, and H2. So our initial CO we're given as 0.110 molar. Same with our H2O. And then we have 0 of our products. Our change here is just going to be minus X, and our change here is plus X. And so our equilibrium is going to be 0.110 minus X for our reactants and X for our products. So now we'll go to a new page and set up our Kc equation. So Kc is going to be our concentration of products, CO2 and H2, over our concentration of reactants, H2O and CO. And we know this equals 102. And now we have values for all of these, and we can solve for X and then use that X to find what the exact concentrations are. So the products are both X, so this is just X times X. And the reactants are both 0.110 minus X. And so what we want to do is take what we have here and rearrange it into a quadratic formula where we have sum x squared plus sum x plus some constant equals 0. And when we do this, we end up with 101x squared minus 22.44x plus 1.2342 equals 0. And now we can use the quadratic formula, and when we do that, we find that we have x equals 0.122 or x equals 0.1001. And so we know it can't be this, because if it's this, 0.122 is higher than our initial concentration of reactants, which would mean we would end up with a negative concentration of reactants, which isn't possible. So we know that this is our correct X. So now that we have that, we can find our concentrations at equilibrium. So our concentration of CO2 is just equal to X, so it's 0.1001 molar. Our concentration of H2 is going to be the same, 0.1001 molar. Our concentration of H2O at equilibrium is our initial concentration minus our X value, which gives us an equilibrium concentration of 0.0099 molar. And our concentration of CO is going to be the same, since our initial concentration was the same. So with that, we have all 4 of our equilibrium concentrations of products and reactants.